Hi friends. Today, let's talk about a simple differentiator circuit made using just a capacitor and a resistor. This is called a passive differentiator because it doesn't use an op-amp, only passive components. A capacitor, C, in series with the input signal. A resistor, R, to ground, across which we take the output. How does it work? A differentiator circuit responds to changes in the input voltage rather than the voltage itself. The capacitor blocks direct current DC and only allows rapidly changing signals AC to pass through. What happens when we apply a 40 Hz square wave? A square wave alternates between high voltage and low voltage at a steady frequency. Instead of getting another square wave at the output, let's see what happens step by step. When the input voltage jumps from low to high, rising edge, the capacitor charges rapidly, allowing a sudden surge of current. This creates a sharp positive voltage spike across the resistor. When the input voltage remains constant at a high level, the capacitor blocks DC current after charging. The current flow drops to nearly zero, and the output voltage returns to zero. When the input voltage drops from high to low, falling edge, the capacitor discharges quickly, causing a sudden negative voltage spike across the resistor. When the input remains constant at a low level, no current flows, and the output remains at zero until the next rising edge. Final output of the passive differentiator. Instead of a square wave, the output becomes a series of sharp spikes, corresponding to the rising and falling edges of the square wave. Each rising edge produces a positive spike, and each falling edge produces a negative spike. This is why passive differentiators are used for pulse shaping and edge detection, especially in circuits that need to detect fast changes in signals. So, in summary, a passive differentiator consists of just a capacitor and a resistor. It amplifies sudden voltage changes, not steady signals. A square wave input results in sharp pulses at the transitions. That's all for today. Keep experimenting and happy learning.